Hey guys, what we're going to do today, if I can fix this a little bit, is talk about the workhorse formula. And we may have developed this in class, but I just want to walk you through a proof for it again, because this concept of proving formulas is something we'll come back to a number of times. So just like any proof, any argument, we have to start with things that we all agree to. So we're going to use some of the formulas we've already come up with earlier. One that we're going to use is V average equals delta x over t. Now we can also write V average another way, and I'm going to put a little star here because this is a special case when an acceleration is constant. And for our class, we'll pretty much always assume constant accelerations. When you have a constant acceleration, you can also say final velocity plus original velocity over time. That's all the same. So there's one formula we have to start with. And another that we have is our new definition of acceleration, which is A equals delta V over t, which we can also write as Vf minus Vo, change in velocity over time. So we have these two formulas, and we're going to combine them to turn it into this one. The nice thing about this formula is it brings in acceleration, velocity, time, and displacement, all the different variables that we're going to be working with in our first couple units. So let's get started. The way that we move forward with these proofs, and with any kind of proof, is you usually say, well, what's a step I can take from any one of these places to try to combine them? So let's look for some like terms. Well, we have t in both equations. We only have delta x over here. We only have a over there. But we also have Vf in both. We have Vo in both. And we only have V average over here. So we should pick one of these terms to merge these two together. I'm going to pick Vf. That's what I'm going to use. So what I want to do is I'm going to solve for Vf on this side and then put what I get into this equation. That's going to be our plan. If I said that right, yes. Alright, so let's start. We're going to rearrange this formula a little bit. I'm going to ignore everything in this box. So we're going to start with A equals Vf minus Vo over t. Let's multiply both sides by t times t. Those cancel out. And I'm also going to now add Vo. So this whole thing plus Vo is equal to this, plus Vo. So now what do I have? Vo plus A times t is equal to Vf, because Vo minus Vo canceled out. So here we go. I now have rearranged this equation. I now have Vf equals, which means whenever I see Vf, I can write that instead. So let's go sub that in here and see what we come up with. I'm going to write this again, and I'm going to skip the V average part. I'm only going to worry about this side. And even though we have that special equal sign there, we said this only works for constant accelerations. We're only ever going to deal with constant accelerations. If not, it'll be a very special case, and I'll tell you. So let's sub this in for Vf. We have delta x over t. Oh, and I've already made a mistake. The same one I made in one of these classes. V average does not equal Vf plus V over t. It equals Vf plus V over 2. Now, fortunately, since this is a video, I can very easily start over again and post this like I didn't make that mistake. But people make mistakes. It's okay. I just made one. Here's evidence. But we fix it and move on. So Vf plus V over 2. We have delta x over t equals Vf, and I'm just going to put parentheses there for now, plus Vo over 2. Now, what goes in these parentheses? Well, this. I could write VF, but I could also write that. So let's write VO plus A times T. Well, this is pretty muddled. Let's simplify it a little bit. First thing I'll do is I'll write delta X times T equals, and let's run this out. Well, I got VO plus AT plus VO, so that's basically the same as 2 VO plus AT. I'm also going to distribute this 2. So instead of having everything over 2, I'll put this over 2 and this over 2. Now the reason I did that is because I can now cancel those 2's out. So I have delta X equals VO plus AT over 2. And instead of leaving the T on this side, let's multiply both sides by T. I have to multiply the whole side by T. Well, let's see. T times VO is VO T. AT over 2 times T is AT squared over 2. Now this looks surprisingly like this. There's where our workhorse formula comes from. It's just the same formulas we've been using, but put together to let us talk about velocity, time, acceleration, and displacement all at once. Now, that's also how we're going to do proofs and how we're going to develop new formulas. Start with things that we agree upon, and then just apply the rules of math and logic to come up with some new understanding. All right, that's it for this video. Bye-bye.